Okay, so you have a ball thrown against the wall. Initial velocity of the ball is 15 meters per second. The ball is thrown at an angle of 37 degrees to the horizontal. The wall is 15 meters away. So the first step to almost all of these projectile problems is to figure out the velocity in the x and the y direction. The velocity in the x direction is v0 cosine theta, and the velocity, the initial velocity in the y direction is v0 sine theta. Remember, the velocity in the y direction is going to change, but the velocity in the x direction is constant. So this will give me 12 meters per second, and this will give me 9 meters per second. And it's worth noting that this is constant, does not change, but this velocity as a function of time is going to be v0 plus at. So v as a function of t is going to be 9 meters per second minus 10 acceleration due to meters per second squared acceleration due to gravity times t. So then the question becomes, what is the maximum height? So this is, remember, we can solve this problem kind of three ways. One is to say, look, that the average velocity on the way up is going to be 9 at the bottom, 0 at the top, divided by 2. That gives me 4.5 meters per second. The time to get to the top is just the initial velocity divided by the acceleration. So 9 divided by 10 is 0.9. So the height is equal to v average times t, 4.5 times 0.9 is 4.05 meters. We can also say, oh, I'm going to use the v squared is v0 squared 2a delta y or delta d. Velocity at the top is 0. The initial velocity is 9, that's squared, plus 2 times minus 10 times delta y. So 81 divided by 20 is 405 meters. And then last but not least, if you really wanted, and that's probably easy, I'm going to stop there. So, wow, actually, the last way to do it is, again, we know that time to the top is 0.9 seconds. So y is equal to y0 v0y times t plus 1/2 at squared. Y is equal to, it starts out at the ground, plus 9 meters per second times 0.9 seconds plus 1/2 minus 10, 0.9 quantity squared. And if you do that all out, you still get 4.05 meters. And really, you can kind of solve the problem whatever way you'd like. Important thing here is to remember on this equation right here, for our purposes, we need to remember that this is velocity in the y direction, and this is acceleration in the y direction. So the question then becomes, how high is it when it hits? So what we figured out so far is that it's going to make some path like this. We don't know whether or not it's going to be going up or going down, but we can start thinking about that by recalling that the velocity in the x direction is 12 meters per second, and the distance in the x direction is 15 meters. So therefore, the time that it's going to take to get there is going to be 15 over 12 which is equal to 1.25 seconds. So we now can use that position equation for y. Y is equal to y0 v0y times t plus 1/2 at squared. And if we just plug numbers in, 0 plus, remember the velocity in the y direction is 9 meters per second times a time of 1.25 seconds plus 1/2 minus 10, 1.25 seconds squared. And if I do that all out, what I find is that the height on the wall is, and let me double check that because I don't want to mislead you, is 9 times 1.25 plus 1/2 a t squared, and I get 3.44 meters. So that's how high. Now the question is, when it on impact, is it going up or going down? Well, one thing that you remember is that time to top was equal to 0.9 seconds. Time to wall is 1.25 seconds. So therefore, it must be on its way down. It must be coming down at that point. And we can also confirm that by saying, well, the velocity at that point is going to be the initial, is v0y plus at. That's going to look like 9 meters per second minus 10 times 1.25. And if I do that out, I get minus 3.5 meters per second, so that it's clearly going down. So if you imagine now I have a vector in the x direction of 12 meters per second, velocity in the y direction, not drawn to scale, of 3.5 meters per second, then the velocity is going to be, so the magnitude of the velocity is vx squared, vy squared, and if I plug numbers in, that's going to look like 12 squared plus minus 3.5 quantity squared, and that gives me 12.5 meters per second, and then the angle is just going to be the arctangent of the y value, 3.5, over the x value, 12. Remember, that's minus 3.5. And if I do that out, I come up with an angle of minus 15.6 degrees. And, that makes sense. I didn't draw this to scale. If I drew it to scale, you'd have 12, and then you'd have that being about 1/3 the length, 1/3 to 1/4 the length. So it's not hard to argue that that is about 15 degrees. And that's it.